Retro.
Yeah.
Electro. Tech.
Oh yeah.
Hey, turn the lights back on. Wow. Retro Electro Tech. When real audio ruled the world.
Well, hello there once again, ladies and gentlemen. This is Retro Ernest of Retro Electro Tech. And here on the bench today, I'm going through a Pioneer SX780 that came to me with a complaint that the relay was behaving intermittently, dropping in and out. So I will go into what I ended up discovering. So initially I wanted to power up this unit, of course, and in doing so I wanted to do so safely. So I used the current limiter / dim bulb tester. I talk about that often. In this video I'm going to go ahead and skip that, but during the safe power up on the current limiter there was no indication that this unit was trying to draw excessive current. Everything was stable there, everything remained rock solid. However, the protection relay would not engage. So I was working on several pieces of equipment yesterday. Well, I always am, actually, because I'm so bogged down with work. But I bring that up because I was getting into some troubleshooting on this off and on throughout the day yesterday as I was working on other equipment, is the point. So it wasn't until later in the day yesterday that the relay engaged, clicked back in, and everything was fine. All was good in the world. And I ended up coming in this morning bright and early, long before I actually opened. So I've been in here now for about 4 hours, and when I got in this morning I powered this unit on again. No problems whatsoever. Relay engaged. Everything is good. So what happened that made the relay click back in and remain engaged? I'm not 100% sure on that, but I have some theories, and I'm going to get into that as I go through some of my troubleshooting procedures that I started performing yesterday, actually off and on, like I said, in between working on other stuff. And even though the unit is working right now, I'm just going to go over some of those procedures for you guys, and a little bit of reinforcement for the customer's peace of mind as to what I did to kind of test things out and the process I went through, because I'm going to send him the video as well. But otherwise, yeah, like I said, it's rock solid. The relay engaged, and as I already said, I'll get into what I think may have been the cause of that happening. So let me go ahead and dive in and start going through that process. Alright, so before I get started on some other stuff, I wanted to focus in on the relay. It is engaged at this moment. You can see the green LED. So I probably should have, okay, it just kicked out right now. Not a surprise. So what I was going to say, now it kicked back on. Okay, so we obviously have the problem that the customer was originally experiencing with the relay kicking in and out. Remember I said that yesterday when I first powered it on, the relay just wouldn't come in at all until later in the day, when I thought I may have honed in on what was causing the problem, even though I wasn't 100% sure, because I was going around checking connections. I was pushing on the circuit board with a non-conductive pointer. I thought maybe I stumbled upon a connection issue, and my plan was to bolster up a bunch of connections and really reflow solder joints, which I'm still going to do. But also too, I thought that maybe the relay, that something was stuck. So my course of action, if this would have remained rock solid and I wouldn't have experienced any problems as I'm experiencing now, my plan would have been to just, again, clean up connections and all that jazz and probably hand it back to the customer if it would have continued to perform rock solid in the coming days. So I don't really think that it's a connection issue, as I thought yesterday, because I was messing around with some stuff on the board. I was kind of flexing the board. I was moving some wiring around. I was just going through and moving some of these components. Again, involved in the protection / relay circuit. I was doing all that, and then like a few seconds or so after, boom, the relay popped on. It wasn't immediate, but it popped back on. So I thought, I might be onto something there. And I'm saying this because I don't think that the relay issue is on account of a fault that's driving it into protect mode. I think it's originating from the relay / protection circuit. I think there's something intermittent going on with one of these components. It could be the relay itself. This is not the original relay. There has been work done in here. There's been some recapping and a few things, excuse me, and also too, it looks like somebody replaced the STK amplifier modules. Okay, so that's another story, but I can tell you that those modules are functioning, because when I didn't have the relay yesterday, I went into troubleshooting mode and I wanted to see what we had going on, if there was a module that pooped the bed, or both modules had pooped the bed, if there was something going on in the amp section or even the preamp section. I was checking signal, checking voltages, and everything looked okay, is my point. So that's why I think that we've got an intermittent issue going on, probably with this chip, maybe the PA3004 chip, which is a common point of failure. They do get fickle. Maybe even this this driver transistor here that drives the relay. I don't know. There's this timing cap too. I think this is the timing cap, but this looks like a new cap. So I don't know. But I think, like I said, I'm going to go ahead and rebuild the protection circuit and the relay circuit. And then I think we'll be good, because I don't think there's something else going on that's causing a fault that's kicking out the relay. Let me back out of here. I will be looking into the power supply in a little bit more detail though, and really monitoring voltages in the power supply, because of course the protection circuit is obviously sensitive to voltage anomalies and changes, fluctuations and all that. So I will be monitoring that in a little bit more detail. So let me just start there and go ahead and move on. So while I got my relay, I'm going to check DC voltages on the speaker terminals and make sure everything is looking okay there. So let me switch views back over to the multimeter. Okay, so here's our right channel. It's bouncing around in the low 20s, about there. Let's check our left. Bit lower, so you can see bouncing around between about 4, almost 5 volts. So there's that. It's not bad. All right, so here we are looking at the back side. Here is our STK modules here, our amplifier modules, chips, whatever. And I could tell that these are not, well, I don't know for certain if these are the originals. I don't think so. I don't have that committed to memory, again, like I explained earlier, or I may have explained earlier, which ones are the reproductions, fakes, counterfeits, whatever you want to call them, versus the originals. I can tell that the soldering is new, and so I'm assuming that they changed these modules, okay? So, and if they are the original and they just pulled them out just because they wanted to maybe apply new heatsink compound and then slap them back in, I really don't know. I don't think that's the case. I think they've been replaced. But anyways, neither here nor there. I mentioned that I wanted to start monitoring power supply voltages and all that, and I did, and I'm going to continue to hunt around and do a little bit more of that. But just in the down and dirty troubleshooting phase of things, I wanted to see what our rail voltages were looking like. And I'm not going to zoom in, but there's a couple pins here. They're very evident because they spell it out on the pins. Our VCC and VEE, or B minus and B plus, okay? So I'm going to clip on to that, and we'll take a look at our voltages, our rail voltages, and see what we have. Factory calls for 39.5 volts, okay? And if we drop on down to the meters here, well, just that one, for now. We have our minus 40 point, a little over 40 and a half, okay? And I've been monitoring things off and on, and everything is stable as far as the voltages that I've monitored or have been monitoring. And I'm going to drop down to the B plus pin, same amplifier module, right channel, and we have, you know, again our B plus there. Now down to the next amp module. Here's our B minus, our VEE, and here's our B plus, our VCC. And you can see they're on board with each other. They're the same, okay? They're speaking the same language. Everything is stable. We have the same voltages. There's no, you know, funky deviations or anything like that. No anomalies. So everything's looking good there. Now, let me change views again. So, in going through and troubleshooting things, I wanted to know the next, you know, million-dollar question, of course, is, do we have output? Is there something going on here? And again, remember when I first powered it up the other day, dim bulb tester looked absolutely fine, not a single hiccup. I didn't suspect there was anything major going on as far as any major shorts, anything like that, something trying to draw heavy current. But I wanted to see what the status was as far as whether these amps were putting out. And let me go ahead and just pan down over here. You can see I'm clipped on to a couple of pins down here for our right and our left channel. I could have clipped onto the you know, to the output pins of the amp modules, but I figured now just pick up signal over here where signal leaves the amplifier modules and ends up at the line side of the relay. So let me go ahead and pan back over to the scope. You can see I have signal on both channels. It's a little bouncy and this and that. However, I think that might be on account of I have everything opened up and I have, you know, some noise sources on the bench probably that are causing it to bounce a little bit, but with the top and the bottom opened up, it could be that. I'm pretty sure it is. Now, before I started having problems with the relay kicking in and out again, I had mentioned that yesterday, you know, when I had the relay come back and it engaged, and it stayed that way rock solid until this morning, and about, you know, several hours into the morning, you know, it was rock solid as well. In fact, I had some speakers hooked up because I had checked, you know, when the relay kicked back in and all that, and everything was looking warm, fuzzy, and wonderful. I had checked to see what the status was as far as DC on the speaker terminals. I did that yesterday as well. I'm just going through the same stuff today, mostly for you guys and the customer. But anyways, because everything looked okay on the speaker terminals is my point. I hooked up speakers. I was listening to music. Sounds absolutely great. So I know that what's coming out of these amplifier packs here is adequate enough to sound decent. And there you go. So no funky distortion, no audible distortion, anything weird. Everything's looking good, despite the fact that just a moment ago, you know, when I panned around to the scope, the signal was looking a little bouncy and whatnot. And there is a little bit of a diminished amplitude on the right channel. Yeah, you can hear the relay clicking in and out. There's a little bit of diminished amplitude on the right channel, but it seems to be on lower volume, so I don't know if that's the volume pot or whatever the case. I'll look into that later. That's really not the issue right now. I have bigger fish to fry right now, so as far as any amplitude imbalance between the two channels, you know, I'll cross that bridge maybe later. as far as audibly, they both sounded good, both speakers side by side. There was not any noticeable difference audibly speaking, so there's that. But anyway, so I'm hooked onto the line side, and what happens is, and I'll just explain this briefly, is when the relay engages, obviously from our line side it carries our signal over to the load side of the relay. From the load side of the relay it enters the speaker switches, okay? So over here on the front, you can see my fingers over here. On the front we have our two speaker switches for A and B. So it ends up from the load side of the relay to the speaker switches, and then from the speaker switches it feeds these 4 terminals here with 4 wires leaving the terminals, and these 4 wires leave the terminals and end up at the speaker terminals, the speaker outputs on the back of the unit. Okay, so that's pretty much it in a nutshell as far as tracing everything, the signal and whatnot. So what's going on as far as our relay, our protection circuitry is concerned? Like I said, I think our problem is the relay circuitry, protection circuitry. I think that's where our problems originate from. Okay, so I'm going to get into looking at some voltages and comparing them with, you know, factory spec, our service manual, and see what's going on. So as I said a moment ago, I'm probably going to end up regardless, you know, rebuilding the protection circuit, the relay circuit, because I just want to be sure that, again, there's not going to be any problems. Okay, so this is the part of the board that I'm going to be probing around, and I'm going to demonstrate why I think the relay is dropping in and out and won't stay latched. So first of all, this row of pins here is the protection IC, the PA3004, and then these 2 solder joints here are the timing capacitor. These 3 here are the relay driver transistor. So what I'm going to do is ultimately show what we have going on as far as voltages being produced and why I think the problem is originating here versus outside of the protection / relay circuitry. So based on the testing that I did already with probing voltages, checking rail voltages and other voltages, and I'm going to be doing more of that, as I already mentioned, in a little bit more depth as I get a little bit more into this, and just to be certain. But ultimately we saw that, you know, the rail voltages look good. Everywhere else that I probed voltages, they looked good, including the voltage that's feeding the protection IC. Everything's looking good as far as that goes. There doesn't seem to be any problems with the power supply. And our amplifier ICs, these STKs, seem to be outputting just fine. So, like I said, I don't think there's any problem as far as outside of the protection circuit. And again, I'm going to demonstrate what's going on and what I think is causing the problem. So let me go ahead and turn our attention to a piece of the schematic and kind of show what's going on, or what I believe is going on at this point. Okay, so what we're looking at here gives us an idea of how the protection circuit operates, more or less. And you can also see what this protection circuit, this IC, monitors, okay, right in here. So we know that when we power up a unit, there's that delay before we hear the relay pull in and click, okay? So when we hit the power switch, our B plus is carried over through this constant current circuit here and charges up this timing capacitor, okay? So when this timing capacitor reaches charge, it activates this switching internally inside the chip there internally, and when that switch is activated and the timing cap comes up to charge, then our current, our voltage will continue on down this route here through this constant current source here, and with this switch closed, engaged, it will provide sufficient base current to Q26, which is our relay transistor, our driver transistor, and activate the relay. Okay. So that being said, just keep that in mind, and I'm going to go back to the unit and get a little bit more into what I think is going on. Okay, so again, I'm going to be probing these pins, or these solder joints, this row of solder joints. And again, these are the IC pins, the protection IC. And I probed these pins already and checked voltages earlier on, and everything is somewhat in the ballpark. There's some voltages are, you know, kind of questionable, but for the most part, the ones that I'm going to, you know, talk about here are what I think is causing the problem again. So this first pin over here is the supply, the 13.5 volts, and that's pretty much spot on. And then there's this little space in between here. There's no connection for pin 2. Pin 3 is the pin that needs to provide our base current to that 2SC 1384 relay driver transistor. This is the base here. So this is pin 3 of the IC. This is the base pin of the transistor. So let me go ahead and fire this up. I don't know when things are going to start kicking in, but when it does, I will show you what voltage we're getting at the base of our driver transistor. So I'm going to tell you right now that according to the service manual, we should be getting 0.9 volts or 900 millivolts at the base to turn that transistor on and, you know, get current flowing through the relay coil and all that. Okay, so it's got to be turned on. And let me go ahead and swing the camera around to the face of the meter. I'm probably going to have to edit some of this because I don't know how long it's going to take for things to kick on and kick in and all that. So during editing, I'll kind of shorten it up so that we can get to the meat of what I'm referring to. Okay, so I just turned on the receiver. I haven't heard any relay clicking, but let me just for starters, probe pin 1 and show that we have our well, 13.2 volts, whatever. I think the manual calls for 13.5, but we're there. We're sitting pretty close. And once I hear the relay kick in, so here's pin 3 right now of the IC. Okay, so we have what, like about 3 millivolts right around there. Yeah, 2.8 whatever millivolts on pin 3. So as soon as things decide to wake up and kick in, we should see a you know, what is to be our base emitter threshold voltage to turn on that transistor and in turn you know, switch on our relay, or kick in our relay and cause the contacts to close and all that. So let me just actually probe the base of our relay driver. Okay, so I'm going to sit there for just a while. So as I mentioned, while we're waiting here for this thing to kick in, as a matter of course, I'm going to be changing out multiple components in this circuit here for good measure. And depending on how the relay behaves once I change the IC, and I'm going to go ahead and change out that transistor as well. I think the timing cap is okay. In fact, I checked the timing cap. I checked it in circuit, but still, it's a 33 mic 16 volt cap, and it was looking good. And I checked some other components as well in that circuit, and everything looks like it's doing okay overall as far as, you know, resistor values and all that stuff. Everything's pretty much right in the ballpark there within tolerance. So okay, so the relay just kicked in, and you can see we have right about 675 millivolts. Okay, and factory calls for 900 millivolts. So the base emitter threshold is not being met, and I think for this circuit that's important. That transistor needs to fully turn on so that we can get the sufficient or a sufficient flow of current through the relay to hold it, to keep it on, keep it from behaving intermittently and dropping in and out, and just to turn on, period. So this IC isn't providing the base voltage / current after that delay provided by the that time constant of the timing capacitor. Once that timing capacitor is charged up, and this chip is just not activating that internal switching, and hence there's not that turn on going on at the base of the transistor. So it's just not providing that voltage that close to 900 millivolts. We have about 670, let's say. So we're just about 230 millivolts shy of where we should be, and I think that's, for this circuit that's a little flaccid. So yeah, it's just not operating properly, that chip. So I'm going to go ahead and leave it at that. So what I'm going to do, and let me go ahead and change views real quick. So like I said, I'm going to source another IC, and also too, I know that there's also some kits you can get, I think, if I'm not mistaken, some boards, and you can populate them with some discrete components to do the same job of this IC, but I really don't want to do that in this case. I think I'll just hunt down an IC. I know they're going to be a little bit more costly, but whatever. That's just par for the course, because I just want to get this done. So I want to get the IC on board, get another transistor in there, check out some other things. Again, I'm going to be doing a lot of reflowing of solder joints. I really want to bolster up solder joints on this thing, because after looking a little closer, I can see some solder joints that, although they're all right, they could definitely be better. So I just want to make sure everything's really, really, really tight when it comes to solder joints, connections, and all that, and get that squared away. Now, if for some reason there's still problems with the relay, I'll go ahead and replace that. But by the time I go through this protection circuit, relay circuit, I'm going to have everything squared away there. And like I said, I truly doubt if it's something going on elsewhere in the the preamp or the amplifier, or something that's causing some kind of voltage anomaly that's tripping the protection circuit. I just don't think that's the case. So anyways, I'm going to leave it here, guys. This is going to be part 1. When I get everything squared away, I will be back for a part 2, get everything tested, and I have a feeling that everything's going to behave after that. So I'm going to leave it here, this part 1, and as I always say, guys, peace, love, music, and the vintage audio that brings it to your ears. Till next time, y'all take care.
This has been a Spinning Head production.
Hehehehe